test for convergence. So one of the important method is nothing but the D'Alembert's ratio test. D'Alembert's ratio test, this is the method to know the convergence and divergence of the series. Just now I told you the nature of the series are of the three types. That is nothing but the convergent, divergent, and the oscillatory series. And the categorization of the series. Generally, if you see the series we are categorizing series into many types. The first one is the positive series. Positive series. Positive series. So in the near lecture, we can understand what is a positive series. Positive series is the series in which all the terms are positive. That type of series is called as the positive series. Plus minus series. Plus minus series. The series which is having plus minus signs, that is called as the plus minus series. And we are having a special case of the plus minus series, that is we are calling as the alternating series. Alternating series. What is this alternating series? It is basically a plus minus series, but it is having the plus minus in orders. 1 plus, 1 minus, 1 plus, 1 minus, or first minus, then plus, alternate plus minus signs. That type of series is called as the alternating series. That is the basically plus minus series. Now we are having different tests, different tests for this different series. Now today we are going to discuss only one famous test, that is called as the D'Alembert's ratio test, to know the nature of the positive series. We are having many tests for checking the positive series. Some standard test by using the word GB series test, by using the p-harmonic test, test for convergence, comparison test, Cauchy's entail test, Cauchy integral test. Then this is the D'Alembert's ratio test. There are many tests are there. Today we are going to discuss the D'Alembert's ratio test, and that is only to know the nature of the positive series, not the plus minus series. Okay? So already that is positive series. Positive series is the series in which all the terms are positive. So now we want to know what is the nature of the positive series. Positive series example, we can write like this. For example, you see this positive series I am writing here. Here we have taken in the test also. Let summation will be the positive series. I am writing an example. Here I am writing, that is summation 1 by n. Summation 1 by n. This is a positive series. We can write in the expanded form as 1 by n plus 1 by 2 plus 1 by 3 and so on. 1 by 4 and so on. This is the positive series. Why this is positive? Because all the terms are positive. That's why this is called as the positive series. Now I want to know, I will also bring up a simple series for the sake of understanding summation yn. We can take complex examples also. But if you understand the simple, then you can go from simple to the what complex things, difficult things also. So let us see what is the definition and what is the method given by the D'Alembert's, and that is called as the ratio test. Why ratio means the formula given by him, it is in the form of the ratio. That's why this is called as the D'Alembert's ratio test. So what is the condition taken by him? See, let summation mn be the positive series. So first condition, it should be whatever the series you are checking for the convergence, that should be a positive series. And the formula given by him is n tends to infinity, mu by n plus 1. Mu n is nothing but the nth term, and mu n plus 1 is nothing but the n plus 1th term. Now what we have to do? We have to calculate the limit of this ratio, mu n by mu n plus 1. That is equal to, if the limit exists, that is equal to some L. Then based on the n value, we are having different conditions. If L is greater than 1, then the series is said to be convergent. If L is less than 1, then the series is said to be divergent. If L is equal to 1, test fails. Test fails, what does it mean test fails means? This test is not applicable. You have to go for the different test. You have to, and if you see in the sequence and series, we are having systematic procedure. In this test fails, what we have to do, we are having procedure also. So let us see one example on this one. This is the one definition. And Sometimes we can define in that way also. Limit n tends to infinity, instead of taking un by un plus 1, we can put un plus 1 divided by un ratio also, and suppose that is equal to n. Now you see that condition, before condition, what was the condition in the before slide? If you see L greater than 1, series is convergent. But here, because we reverse the ratio, that's why L less than 1, series will be convergent. And if L is greater than 1, series will be divergent. If L is equal to what? Test phase. So that is, the condition is applicable according to your formula, what we are going to choose. Limit n tends to infinity, un by un plus 1 you are taking, or un plus 1 by un we are taking. Let us take one example so you can understand. And just now I tell you, if the test fails, what we have to do if the ratio test fails? If the ratio test fails, so one can go for the Rabbit's test. At that particular point, you can apply the Rabbit's test. And again, this is for the positive series Rabbit's test. The condition is, let's summation given be the positive series. And the formula is nothing but limit n tends to infinity, n into un by un plus 1 minus 1 equal to L. This is the formula given by the Rabbit's. And that value equal to L. Again, we are having the same condition as we learned in case of the DLMS ratio test. N is greater than 1, series is converges. If N is less than 1, series diverges. N is equal to 1, test phase. So whenever the ratio test phase, we will go for the Rabbit's test. And sometimes if it involves A, then we can go for the logarithmic test also, because of the time constant. Just we are focusing on the ratio test and the Rabbit's test. So I will take one example. We will get the clarity regarding. Let us take the one problem on the ratio test. Now the problem is like this in the sequential series. Test for convergence of the following series. Always test for convergence. What does it mean, test for convergence? We want to know whether the series is convergent or not. That's why we are writing the question in this way, test for convergence of the following series. The series is given as x by 1 into 2 plus x square by 2 into 3 plus x cube by 3 into 4 and so on, plus x power n divided by n into n square plus 1. This is the series. Now we are writing, directly we are writing what nth term we are writing. Nth term is nothing but the nth term of the given series. It is positive series. We can easily apply what the ratio test, that condition is satisfied. We are writing summation un. Summation un we will be equal to, we are writing the nth term. You can see here, this is the nth term. That is reality given. This is what nth term. If that is not given, you can easily calculate also. Here by mistake here n square came, but this is not the n square. Actually it is n into n plus 1. Here you can see here, if the nth term is not given, for example, if this trend is not given, then how to calculate the nth term? How to calculate the nth term of the series? You see here in the denominator, we are having what 1 into 2, 2 into 3, 3 into 4. I am taking only the first terms. What are the first terms? 1, 10, 4, and so on. These are the first terms. Now, I am taking the difference. And taking the difference, 10 minus 1. 10 minus 1 equal to 1. I am taking 3 minus 2 equal to 1. If I take 4 minus 3, that is also equal to 1. So what does it mean? If you remember, in the AP series, we discussed this. If AP minus 2n, the second term minus the first term is equal to the 10 minus 2p, if all are equal and so on, that is equal to 10n minus 3n minus 1. All are equal. So we are calling this as small d, and that small d is called as the common difference. That is called as the common difference. So we can say that if the T1 minus Tn minus 1, this difference is same. For example, T10 minus T1, T3 minus T2 is same, then we can say that this series is in AP. This series in AP. And we are having a ready-made formula to find the nth term of the AP series. The formula is T1 will be equal to A plus M minus 1 into D. This is the formula for finding the nth term of the AP series. Here, what is A? A is nothing but the first term. A is the first term. A is the first term. A is the first term and A is nothing but the common difference. So here we see D equal to 1 we got now. A equal to 1 here and D equal to 1. Now we are substituting. What is the nth term? Tm will be equal to, we can write this as 1 plus minus 1 and 1. If you simplify this, you are getting as the n. So that's why you see here we are writing this as what? In the denominator, we are writing the first is nothing but the n. In the same fashion, if you take the second one, second terms, that is nothing but 2, 3, 4, and so on. Here also, if you see, the common difference is d equal to 1, common difference is 1, and but here a equal to 2. The first term is nothing but 2. We are finding in a same by using the same logic. The nth term, that is 2 plus n minus 1 into 1. If you simplify this, we are getting this as n plus 1. So that's why by seeing this behavior, x plus x by 1 into 2 plus x square by 2 into 3 and so on. If you see what is the power of the x, that is nothing but the 1, 2, 3 and so on. That's why just now we have seen that is nth term is nothing but the n. So we are writing this as x power n divided by n into n plus 1. So this is nothing but what? The nth term of the series, nano series. Here the nth term is given. If nth term is not given, like this logic we have to apply and we have to write the nth term of the series, and that is nothing but the summation un. We have to write. This is. And one more thing you have to understand, how to verify whatever the nth term written by you, that is the correct one. How to verify? You have to substitute n equal to 1 to 3 and so on in the nth term, and in turn you should get the series. In turn, you should get the series. If you are not getting the series, so some mistake is there, some error is there in your nth term. So like this you can verify. And one more thing, sometimes what happens whenever we are writing the nth term, we unable to cover all the terms of the series. So in those cases, you can do something like this. You are having one property of the series, finite number of deletion or the addition of the terms to the series will not alter, will not change the nature of the series. So we can remove some terms or we can add some terms in the series. So in that way also, I hope you are following how to write down the nth term of the series. So this is a what? Positive series, and nth term is nothing but x power n divided by m into n plus 1, that is the nth term. Now, what we are writing according to the formula, we are writing what? We want un plus 1. Un plus 1. And un plus 1, some student face difficulty. Generally, some students face difficulty in writing un plus 1. And that is very easy to understand. You look here, un plus 1, you see this. What is the nth term? Even we are having the nth term is nothing but un equal to, we are having as x power n divided by n into n plus 1. This is nothing but the nth term of the series. Now what we are doing, how to write un plus 1? Simply what we are doing, we are replacing n by n plus 1. Why? Because while teaching, I experienced this. So many students, they are unable to understand how to write the un plus 1. That is the very easy thing. We have to replace n by n plus 1. Wherever n is there, at that place you have to write the n plus 1. For example, you see here, we are writing this as what? Un plus 1 we are writing. Un plus 1 means there is nothing but we can write as un plus 1 will be equal to x power n plus 1 divided by n plus 1 into n plus 1 n plus 1, that is plus 2. So this is nothing but what? N plus 1 plus n plus 1 plus 1. That is nothing but x power n plus 1 x plus n plus 1 divided by n plus 1 into n plus 2. This is nothing but your un plus 1. Un plus 1. Then now we got what? Un we got and un plus 1 we got. Now we are applying the limit n tends to infinity. We are taking the ratio un by un plus 1. Now we are simplifying that one. We are simplifying. After the simplification, you see here, we are getting by taking common or just thing cancellation. And as my I as n tends to infinity, 1 by n is to 0. So finally, we are getting this as this is equal to 1 plus 0 divided by x we are getting here. That is 1 plus 0 divided by x. So final answer we are getting as the 1 by x. 1 by x. And how we are getting this? Un by un plus 1. You can easily understand this. This is actually limit n tends to infinity un by un plus 1 value. That is we are writing as, this is as it is, limit n tends to infinity we are writing. What is un x power n divided by n into n plus 1. Now I have to take the inversion I have to take. Shall I take the reciprocal? Reciprocal. What is un plus 1? Un plus 1 is nothing but n plus 1 into n plus 2 divided by x power n plus 1. This is the ratio. Now you can do some cancellations. How we are doing the cancellation here? You can clearly observe here. Limit n tends to infinity. We are writing this as it is we are copying x power n divided by n into n plus 1 as it is we are writing. Here, this is also we are writing n plus 1 into n plus 2. Here we are writing this as x power n into x. X power n plus 1 can be written as x power n into x. Here x power n gets cancelled. Here now we are taking what? N common. Now right? N tends to infinity. We are taking n common from the numerator, from this factor. N common 1 plus 1 by n we can write. Here also we are taking n common. We can write this as 1 plus 2 by n divided by, here n already there. Here also we are taking n common. If you take n common, this can be written as 1 plus 1 by n. And this x is remain as it is. Now you can do the cancellation. This n, this n, this n, this n gets cancelled. And as we noted, as n tends to infinity, as n tends to infinity implies 1 by n always tends to 0. So wherever we are having 1 by n term, we can substitute 0. So finally we are getting this as, if you apply the limit, finally we are getting this as, that is 1 plus 0, and here also 1 plus 0, and divided by here also we are getting 1 plus 0, and x is as it is. So finally this is nothing but limit value we are getting as that L. Generally we have taken in the definition as L. So generally we got this as limit value equal to L, which is nothing but 1 by x. We got the limit value, the limit of the ratio un by un plus 1 equal to n1. Now we are applying the conditions. Already we discussed the conditions. Let us recall the conditions. The first condition is L is greater than 1. Series converges. Series converges. Converges. Second condition, L is less than n. Series diverges. Series diverges. And the third condition, L equal to n, test fails. Test fails. So these are the conditions we are applying. Here because L equal to we got as 1 by x, now we are writing the series converges if 1 by x is greater than 1. 1 by x is greater than 1 means that is nothing but if x is less than 1, if we cross multiply, if x is less than 1, then the series, the result of the series is nothing but the conversion. If 1 by x is less than 1, that implies nothing but x greater than 1, the nature of the series is nothing but the diverges. And test phase 1 by x equal to 1, that is nothing but x equal to 1 the test phase. So this we got, by applying we got ratio test to the positive series we got this. And generally whatever we took for in the example, actually we have taken a power series in which the x is n1. Now further, now we have to know the nature of this, but the ratio test fails at x equal to 1. Now we want to know what is the nature of the series at x equal to 1. If we substitute x equal to 1, already we are having nth term. Nth term is nothing but here we are having nth term. This is x power n divided by n into n plus 1. We are substituting x equal to 1. If you substitute x equal to 1 power n divided by n into n plus 1, that is nothing but 1 by n into n plus 1. Now this is the nth term. Why we have substituted this x equal to 1? Because our ratio test unable to know the nature of the series at the point x equal to 1. Test fails. That's why we substituted x equal to 1. Now we want to know what is the behavior of the series at the point x equal to 1. Now again what we are doing, we are taking the n plus 1. That is nothing but just now same thing. 1 by n plus 1 into n plus 2. Now we are applying the Rabi's test we are applying. What is the formula of the Rabi? Just now I told you there is nothing but Rabi's test formula is limit n tends to infinity n into mu n by mu n plus 1 minus 1 minus. This limit we have to calculate. If it is equal to n, again it is having the same condition as the ratio test. If this we need to calculate. Now we are calculating that way. We are taking n tends to infinity 9 by n plus 1. Here we wrote the formula. Now we are applying that way. Already we are having got the simplification. n by n plus 1 already we calculated previously. From there we are directly taking. After doing the simplification, just now I showed you how to calculate the limit. Same steps we are following. We are taking what n common from the numerator from the denominator. First we are taking the LCM. Then we are taking n common from the numerator, n common from the denominator. We are cancelling all those things and we are writing maximum terms in the form of 1 by n, 2 by n, something like this. Why? Because as n tends to infinity, 1 by n tends to 0. So finally we are getting as the limit value as the, we are getting this a value as the 2 we are getting. And 2 is greater than n obviously. So therefore, by Rabi's test, we can say that the condition is L is greater than 1. By Rabi's test, the series will be converges. So therefore, we can say that the behavior of the series at x equal to 1 is nothing but the convergent. And that we got by the Rabi's test. Now finally, we can write the what complete investigation of this problem, positive series nature. Already we got x less than 1 in the previous slide. X less than 1. Already we got x less than 1. The series is what? Converges. And x greater than 1 diverges. And here now we got x equal to 1. The series converges. Now we are combining all these statements. Final conclusion is nothing but if x less than or equal to 1, the series is converges and the series is diverges or x is greater than 1. So this is the procedure to know the what nature of the series by applying the D-Alembert ratio test and the Rabi's test. I hope you understood the concept. In actual today what we discuss, first we discuss what is the definition of the set, that is the prerequisite thing. Then we discuss the definition of the function. Then we define sequence, and I focus a little bit regarding the what significance and the importance and the application of the sequence and series. We learn definition of the sequence and some example pertaining to the sequence, then series, and particularly we focus on how to know the convergence of the series. And we have taken we learned one famous method to know the nature of the positive series. That is nothing but the D-Alembert ratio test as well as the Rabi's test. I hope all of you understood this concept. Thank you, and all.